So this is Melody, made by Hasbro in the 70s, and it's a toy that I had when I was 6 years old. Now, anyone who knows me would know that this is really strange because I hated dolls, and I hated anything girly. Everyone knew the best superheroes were men. So the thing is that this toy didn't just sit there like regular dolls. This one came to life and had a voice through sound and music. So nowadays, I am a professional product designer. And I work on things that seem mundane, like cameras and washing machines. But what I really like to focus on is bringing those objects to life, much the way the doll came to life. And I do that through technology, electronics, code, form, and sound. So what I want to do today is I want to show you a few of the more experimental projects that I do in order to get experience with the new technologies that we may not have used before. And I'm going to show you a few existing projects and then from the past, and then some that are more recent. So this is a project that I did when I was in graduate school, and I was trying to reimagine the remote control. And what I was thinking about was how we embrace a remote control and how TV gives us comfort. So in this vision, you rub this teddy bear's belly and you gaze into its face in order to see the interface. But quickly, because I was interested in the interface, I realized that I would have to do programming in order to really bring things to life and really understand their behavior and craft their behavior. So this is one of the first projects that I did several years ago to explore code and how can I make an object come to life. And in this object, I built structures that actually represent music. And we can go to that. And you'll see I tried to take forms as simple as a box and use them to bring musical structures to life. So we know what we think about the musical notation. So this is an alternative to that that can make people who don't know about music composition, and anyone at all, use the interface. So in this first interface, I'm envisioning a chord. And we have a C major scale that's laid out. The next part is a rhythm. So I'm envisioning kind of a building structure where each floor has a different rhythm attached to it. And you can pull the rhythm apart to make it go more slowly. And you can turn beats on or off. And you can change the tone. And you can explore that online. It's called Repercussion.org. And I also was asked to show this work in gallery settings and thought about not having a mouse and a keyboard, but having an environment. So I set it up with sensors so that the position of your body would map to the different types of sounds. But I still was very excited about the physical object and seeing how I could use sound and electronics in order to bring physical objects to life. And in this next project, I was invited to do an installation in a campus in the south of France in a town called Lacoste. And the environment was a very rough, cavernous interior. And what I wanted to do was I wanted to take a number of identical physical objects and see if I could give each of them a character just through electronics and sound. And what I did was I envisioned this space where I took 150 empty eggshells, which I carried in my luggage, and nestled them in the crevices of the rocks inside this rough, cavernous interior. They were all identical eggshells except for an LED and an RFID tag. And there's a sculpture in the middle of the room which is made of wax. Inside the sculpture, it can read the RFID tags. So what happens in this installation is there's a sound that's mapped to each of the eggs. And when the egg is placed in the nest, it plays that sound as an ambient sound in the room. I was also invited to do the same sort of installation at the Jepson Center for the Arts Museum in Savannah, Georgia. So instead of the cavernous, rough interior, this was the clean white box of the gallery. So I slightly changed the aesthetics to have plastic balls, as you see here. And here's a little video of someone interacting with it. Okay, can we have... So she's really making the effort to choose the ball. So a few years ago, when I was a visiting professor at Georgia Tech, I had the pleasure of working with a woman named Andrea Tamaz, who was building a humanoid robot platform called Simon. Simon, the idea with Simon is that it's what I call the extreme of interface. It's a machine that you interact with by talking to it. And it can also see you, so you can gesture, you can hand it objects. There are cameras in its eyes and microphones. And we were a team of mechanical engineer, artificial intelligence specialists, computer programmers, and Andrea. And I was in charge of the shape of Simon's head, or the aesthetics of the shell. So we began by establishing a design aesthetic, and what we were trying to do was balance the aesthetic of a machine with that of a creature. We didn't want to be too creature-like because learnings in the past showed that that actually frightened people. But we didn't want to be too machine-like because we wanted people to interact with it in a natural way. So we began by drawing, and these are just a couple of my sketches of trying to envision what this robot might be. We also wanted it to look fairly young, so we gave it a youthful approach so that people would understand that it was always learning and looking to you for guidance. So in terms of bringing objects to life, this is really, you can't beat a robot for trying to do that. We built in several modes of expression. So this shows some of the way that we were trying to build eyebrows. So there are magnets behind the shell with slots so that an eyebrow could move up and down. These are some experiments that I did with the mouth to see how the mouth could move. And then, you know, it's not necessarily a human, so we were able to take liberties. And what we did is we decided to build in ear pods that actually, and we said, let's put some lights in there. It'll be an extra mode of expression. We didn't know what we would do with it, but what we learned was that we used it to show that the robot recognized a color. This robot, you can hand an object and it holds it up to its eyes. And we found that even though that's not a human language, it was a nonverbal language that people understood intuitively. They knew what the robot was thinking. So here are some of Simon's expressions. And then this is a little video of what it looks like when Simon is handed an object. So someone has said, Simon, take this. Simon says, okay. And they say, where does it go? And Simon actually has a voice, and it says it goes in the red bin. And you see that those ear pods have turned red. and now someone hands it another object, and it will actually say, she'll say, where does this go? If it hasn't seen green before, which is what this object is, Simon will actually shrug his shoulders and say, I don't know. And then that's how it learns what green is. So he says, not sure, and here he kind of does this little gesture. So then the final thing that I wanted to show you are these last two things. The thing with developing new languages in this with electronics is that it's really something completely new, and we don't have an established tradition around it. So it's very important to try things out and try them out in real time. So sometime last year I was invited to do a residency at the Museum of Arts and Design, which is in Columbus Circle in New York City. And I'm going to go through these fairly quickly, but they're on my website. I did a number of experiments all around form, code, electronics, and sound. And the first one doesn't have any sound. It's a lamp. But when you tilt it on its lower side, it turns off. And when you tilt it so that it's taller, it turns on. And this next one is a box. And when you open it, there's a tone that's generated. The tone is louder the more the box is open, and quieter when it's closed. This is a shape that as you squeeze it, it changes the pitch of a sound. And this is what I call the matrix mask. When somebody speaks into it, there's an actual animation that happens at the nose of that mask, which will respond to the person's voice. And this is the rhythm box. So there are a number of blocks, and depending on where you put it, it will create a rhythm that maps to where the blocks are positioned. And then this last piece, I did also a number of what I call robot characters. And this is ongoing work. So what I did is created a toy that comes to life through code, sound, and electronics. So there are LED lights behind the surface, and they can be programmed to show a facial expression or an animation. In this case, there's an animation of a heart. And I've also been working with some musicians to program actual musical pieces that are on the circuit board inside the toy. So here's a little video that just shows you what that's like. So everything is generated by the play activity itself. So turning the crank is actually what powers the toy and makes it come to life. So you have to engage with it in order for it to happen. And there's music playing when you turn the crank, and it will actually play the sound off of the chip. And that's what I have for you today. Thank you.